Okay, children, till now we have studied 5 algebraic identities. As you can see, the first one is a plus b whole square, second is a minus b whole square, third a plus b into a minus b, then x plus a into x plus b, and the last one that we did in the last class was a plus b plus c whole square. I hope you understand. Don't treat these as separate identities. In some of the books you will find some of the identities like this. There is a separate identity for a minus b plus c whole square. As I told you, there is no need absolutely to learn separate identities for these, because a minus b plus c whole square can also be written as a plus minus b plus c whole square. And then when you open it out using the above identity, you will get a square plus, in place of b square you will be writing minus b square plus c square plus 2 into a into b. In place of b, everywhere you will keep on writing minus b, and automatically the minus sign will get adjusted wherever it has to be. Okay, now when you open out this bracket, a square, now minus b whole square will be plus. Like you will never get a negative sign in the first 3 terms, a square plus b square plus c square. Then you will get minus 2ab minus 2bc plus 2ca. So there is absolutely no reason to learn a new identity like this, and then if you place a minus sign at 2 places, again you learn a new identity. There is absolutely no need, because unnecessarily if you will learn so many identities, you yourself will get confused where to put a negative sign, where to put a positive sign, and otherwise also in this chapter we have so many identities to learn. So I don't want you to go in for all these new identities. Okay, now today we are going to start with the 6th identity, the new identity, which is a plus b whole cube. Now the identity for this is a cube plus b cube plus 3ab into a plus b. Normally we write b cube in the end, so let's rewrite it. In most of the books you will see the identity like this, 3ab into a plus b cube. Or if I open it out, this will become a cube plus 3a square b plus 3ab square plus b cube. And one more identity, they'll go hand in hand basically, so I'm just doing them together. A minus b whole cube will be a cube minus 3ab into a minus b minus b cube. And when we open out the bracket, we will get a cube minus 3a square b plus 3ab square minus b cube. Now, as I told you, if I look at both the sides of these identities, one side will give you the expanded form, the other side will give you the factorized form. So from here you can easily see the right hand side gives you the expanded form of the identity, whereas the left hand side gives you the factorized form of the identity, because it is a plus b whole cube, which can be written as a plus b into a plus b into a plus b. That means it is a product form, and the product form is known as the factorized form. So these are the 2 identities today we are going to learn. Let's first do the expansion part, how we are going to expand the algebraic expressions using these 2 identities. Now suppose I take the first example as, children, I am not taking the examples from the textbook, I am just taking any example so that you can try out NCERT questions on your own based on these. Now a minus b whole cube, here 2x minus 3y. Okay, let's first take the question on plus, then we'll come over to negative sign. So 2x plus 3y whole cube. So what is your a in this case? That is 2x. b is equal to 3y. Now using the identity, what is the first term in the identity a plus b whole cube? It is a cube. So what should I write? Should I write 2x cube? I hope you understand this is a wrong step. What should I write? 2x whole cube plus 3 a square, you should always put them in bracket, a square into b, which is 3y, plus 3 into a into b square plus b cube, that is 3y cube. Now we'll open them out. We will get 2 cube will be 8, so it is 8x cube plus 2 into 2 is, because here it is 2x square, so 2 square will be 4, 4 into 9 is 36, 36 x square into y. Similarly, when you open out this bracket, what do you get? 3y square, so 3 square will give you 9, 9 into 2 is 18, 18 into 3 is 54, so it is 54 x and y raised to the power 2 plus 3y whole cube, 3 cube will be 27 and then y cube. You can see expanding using an identity is very simple. Main problem comes while doing the factorization. So first let us learn the expansion, then we'll go back to factorization also. Let's take another example. Suppose should I take one irrational number here in between, say root 2x minus 4z whole cube. So what is our a in this case? It is root 2x and b will be 4z. Again, day before yesterday when I took the class, I explained you that this minus sign should not be taken along with b, because we are using the identity for a minus b whole cube. So leave out this minus sign. Other than that, these two numbers will be your a and b. So a will be root 2x, b will be 4z. Now using the identity, we will get a cube. So I will write root 2x whole cube minus, now just follow this identity, a minus b whole cube, it is minus 3a square b, so 3 and bracket root 2x square, a square, into b, which is 4z. Next term is plus 3a, which is root 2x, into b square, which is 4z square, minus b cube, that is 4z whole cube. Now let's open out root 2x whole cube, root 2x whole cube. So x cube is very easy to write, but what about root 2 whole cube? Just look here, root 2 whole cube is actually root 2 into root 2 into root 2. Now root 2 into root 2 will give you 2 and this root 2 will remain as it is. So what can I write? 2 root 2 into x cube minus, again this is a square, so if you simplify this, what will you get? 2x square. Okay, so now let's multiply 3 into 2, 6, 6 into 4 is 24, x square and then z. Here also if you open out this square, you will get 16z square. Now let's multiply 16 into 3 is 48 and root 2 will remain as it is. So 48 root 2 x into z square minus 4 cube will give you 64 and then z cube. So you've understood how to factorize these type of questions which are in the form of a minus b whole cube and a plus b whole cube. And now let's do the application of these identities in solving some questions. I have taken question number 7 from your NCERT book, which has 3 parts. Let's do it first one by one. 99 whole cube can be written as I told you previously also, we want to write them in terms of hundreds, tens, thousands and so on. Rather than writing it as 90 plus 9 whole cube, we would prefer to write it as 100 minus 1 whole cube, because this will make the calculations much easier. Now here a will be your 100 and b will be 1. Now let's write down the identity. A minus b whole cube is a cube minus 3a square b plus 3ab square minus b cube. We will exactly follow the same identity using a as 100 and b as 1. So 100 minus 1 whole cube will become 100 whole cube minus 3 into 100 square into 1 plus 3 into 100 into 1 square minus 1 cube. Everywhere in place of A I have replaced 100, in place of B I have put 1. Now let's simplify. 100 cube will be 1 followed by 6 zeros minus 3 into 100 square. 100 square will be 10,000. So 3 into 10,000 will be 30,000 plus, now 1 square will remain 1 only. 3 into 100 will give us 300 minus 1. Now what you need to do is just add up the positive numbers together. So 300 will be added here and you will get 1 0 0 0 3 0 0 minus, add up these two numbers because they are negative numbers, for 3 0 0 0 1, and now you just subtract this number minus 3 0 0 0 1 will give you 10 minus 1 is 9 9 2 0 7 and then 9. So the answer will be 970299. It means if you multiply 99 3 times, you will get this as the answer. Second is 102 whole cube can be written as 100 plus 2 whole cube. So here again our A will be 100 and B will be 2. So let's write down the identity A plus B whole cube, which is A cube plus 3A square B plus 3AB square plus B cube. You can see it's easy to learn both the identities in A plus B whole cube and in A minus B whole cube. Actually the terms are exactly the same, but there is a difference in the signs. That only you have to remember. In plus you have all plus signs, and minus two places you can see minus signs. So just take care of where to put the minus sign. So let's find out what is 100 plus 2 whole cube. That is equal to 100 whole cube plus 3 into 100 square into 2 plus 3 into 100 into 2 square plus 2 cube. Again, everywhere in place of A I have substituted 100, in place of B I have put 2. So this will become 1 2 3 4 5 6 plus 100 square is 10,000. 3 into 2 is 6, so it will become 60,000 plus 2 into 2 is 4, 4 into 3 is 12, 12 into 100 is 1200 plus 2 cube is 8. All positive numbers are there, so just add them up. 1 2 3 4 5, 1 2 3 4 and then 5. So this will become 106 and then 1200 will be added here. 1208. Addition is very simple, orally we can do. So this will be the answer when you multiply 102 3 times. The third part is 998 whole cube. Now how will you write 998? It can be written as 1000 minus 2 whole cube. So again using the identity A minus B whole cube, and where you will put A as equal to 1000, B equal to 2, you will get the answer. What is 998 whole cube? So that was regarding the expansion of the two identities A plus B whole cube and A minus B whole cube. Now let's start with the factorization part. How to do factorization using the two identities. Let us take the first part of question number 8 of your NCERT book. It is 8A cube plus B cube plus 12A square B plus 6AB square. Now children, first thing is that by looking at the expression, you should know which identity is to be used for factorizing the given polynomial. Okay, otherwise there are so many identities you will get confused. Like in A plus B whole square and A minus B whole square, I told you there should be two square terms in the expression and middle term of the expression should match 2AB. Then only we use the identity A plus B whole square or A minus B whole square. Here in this identity a plus b whole cube, what are the terms involved here? A cube plus b cube plus 3a square b plus 3ab square. That means first thing you should observe is that there should be 4 terms in the given expression, which we already have. We can see there are 4 terms in the given expression. Then there should be 2 terms which are perfect cubes, like in this case it is a cube plus b cube. If you are able to find 2 perfect cube terms, then we can see whether the remaining 2 terms are in the format of 3a square b and 3ab square or not. If they are in this format, then we can write that expression in the form of a plus b whole cube. So let's look at this example. Can we look for 2 terms which are perfect cubes in this case? Look at the first term, 8a cube. 8 is a cube of 2. So can I write it as 2a whole cube? B cube can be written as b whole cube. So I am able to find 2 perfect cubes in this expression, where my first term, that is a, would be 2a and b would be b only. Now I have to check out the other 2, like 3a square b. I will write this in the form of 3a square b and check whether it is matching this term or not. So 3, what is my a in this question? It is 2a. So I will write 2a whole square, and into b, what is my b in this question? It is b only, plus the last term is 3 into a. In place of a I will be writing 2a, and then b is b only, so it is b square. Let's check out, is this term matching this term? So if I open out the bracket, 2a whole square, it will become 2 2s are 4. 4 into 3 is 12. 12a square b. Yes, it is exactly matching this. And the last term, 3 into 2 is 6, ab square. This is also matching this term. It means that the given question is exactly in the format of the identity a plus b whole cube, that is a cube plus b cube plus 3a square b plus 3ab square. So can I write it in the format of a plus b whole cube? So what is my a in this case? 2a. B is b only. So 2a plus b whole cube, which I can write as 2a plus b into 2a plus b into 2a plus b, and that is the factorized form of the given expression. Now suppose had it been like there are 2 negative signs also in the given expression, suppose here and here, as in the second part of your question, then you would come to know when it is satisfying all these conditions, all the terms are being satisfied and there are 2 negative signs, so it will definitely be a minus b whole cube. That you can try out the second part on your own. Now let's do the third part of question number 8. Third part is 27 minus 125a cube minus 135a plus 225a square. Whenever you need to factorize, first of all see which identity you think it can be, and then write down that identity in front of you and try to match it with the given identity, and then we can say yes, this identity is possible to be applied in this question. So again there are 4 terms, so and not all positive signs, so obviously it cannot be a plus b whole cube. It can be a minus b whole cube. First of all, we have seen 4 terms. Second basic requirement is that there should be 2 cubic terms, perfect cube terms. So let me first write down the identity. If I feel it could be a minus b whole cube, so let's write that, a cube minus b cube. Okay, let's write it that way, a cube minus b cube minus 3a square b plus 3ab square. Let's try to write the given expression. First 2 terms in the form of 2 perfect cubes. 27 is a cube of 3, so it is 3 cube, minus 125 is a cube of 5, and a cube is already there, so I can write it as 5a whole cube. So at least I can say my a can be 3 and b can be 5a. Using these 2, let me write it in this format now, minus 3 into a square, that is 3 square into b, which is 5a, 3 and 5a I have chosen as a and b, plus 3 into a, what is a? 3 into b square, that is 5a whole square. So let's check out whether we have written it exactly in the format of the identity. Open out this term and check out with this, because we have written it in the form of 3a square b, and if it is matching this term 135a, it means it is exactly in the form of the identity. So this will give me 3 3s are 9, 9 3s are 27, 27 into 5 will give you 135 into a. This term 3 into 3 is 9, 5 5s are 25, 25 into 9 will give us 225 and then a square. So can we write this as a minus b whole cube, because this question is exactly matching this identity. So I can write it as a minus b whole cube, which is 3 minus 5a whole cube, or I can write it as 3 minus 5a, 3 minus 5a and 3 minus 5a 3 times. So I can say this is the factorized form of the given expression. And now let's start with fourth part now, which is 64a cube minus 27b cube minus 144a square b plus 108 ab square. Again, how to check? There are 4 terms basically. So it could be a plus b whole cube or a minus b whole cube. But as we can see 2 negative signs in the expression, so obviously that possibility is ruled out, that it can't be a plus b whole cube. So let's write down the identity for a minus b whole cube, which is a cube minus b cube minus 3a square b plus 3ab square. So after checking 4 terms, we have to check whether there are 2 cubic terms or not. So look at the first term. 64 is a cube of 4. So it can be written as 4a whole cube minus 27 is a cube of 3. So I can write it as 3b. 27b cube can be written as 3b whole cube minus. After writing the first 2 terms, at least we come to know of our a and b. A can be 4a and b can be 3b. Now let's follow this pattern. Minus 3a square b. What is your a square? It is 4a whole square into b will be 3b plus 3ab square. A is again 4a and b is 3b whole square. Whatever a and b you have chosen from the first 2 terms, you can put them in these 2 expressions. And now check whether this expression exactly matches with this expression or not. So when I open out the bracket, 4 into 4 becomes 16 into 9 will give you 144 and then a square into b. Similarly, the last term, when I open out this bracket, it will be 3 into 3 9, 9 into 3 is 27, 27 into 4 gives us 108 and then ab square. So it is matching this term exactly. So can I say that this given expression exactly follows the format of the identity a minus b whole cube, means all terms are in accordance with this identity. So can I write this expression in the form of a minus b whole cube, where what we had chosen for a and b, a was 4a and b was 3b. So 4a minus 3b whole cube, or I can write it as 4a minus 3b into 4a minus 3b into 4a minus 3b. This is the factorized form of the given expression. Now look at the last part of question number 8. I have discussed all the parts of this question because this was little difficult, so I thought let me clear out all the points here. So 27 p cube minus 216 minus 9 by 2 p square plus 1 by 4 p. Again 4 terms but 2 negative signs, so it can't be a plus b whole cube. I am just writing the identity for a minus b whole cube, which will be a cube minus b cube minus 3a square b plus 3ab square. Children, before doing the questions, you must learn the identity and write it as many times so that you can easily learn the identities. If you will keep on looking into the book for the identity, you will never be able to learn them. Now, what is a and b? First we have to choose that. So look for the 2 cubic terms. 27p cube. 27 is the cube of 3. So I will write 3p whole cube minus. Now look at 1 upon 120, 216. 1 is the cube of 1 only and 216 is the cube of 6. So I can write it as 1 by 6 whole cube. So at least now I know what is my a and b. A is 3p and b is 1 by 6. Now I will be using this format: 3 into a square, which is 3p whole square, into b, which is 1 by 6, plus 3 into a, which is 3p, and b square is 1 by 6 whole square. Now you can open out these and check whether this term is matching this term or not. So when I open this bracket, I will get, let me write it as 3 into 3p square will become 9p square into 1 by 6. So that gives you 9 by 2p square, which is exactly matching this. Now look at the last term. If I open it out, I will get 3 into 3p into 1 by 6 into 1 by 6. 3 to the 6 here, 3 to the 6. So we'll get 4 in the denominator, p in the numerator. So we'll get 1 by 4p. So again, this expression is exactly following the pattern of the identity a minus b whole cube, and hence can be written as a minus b whole cube, where what is your a? A was 3p and b was 1 by 6. So can I write 3p minus 1 by 6 or 3p minus 1 by 6 into 3p minus 1 by 6 into 3p minus 1 by 6. So this was the factorization of the algebraic expressions using the identities a plus b whole cube and a minus b whole cube. So now you are in a position to complete till question number 8 of exercise 2.5 of your NCERT book. Okay, now let us see whether by looking at the expression we are able to find out or guess which identity to be used in a given expression. So look at the first one. How will you go about it? First of all, you will say, okay, there are 4 terms. Till now, whatever identities you have done, there were 4 terms only in those 2 types of identities. One is a minus b whole square, another is a plus b whole square. So either a minus b whole, a minus b whole cube or a plus b whole cube. So if I take a plus b whole cube, I need all plus signs, which is not the case. So can I think of using a minus b whole cube? Yes, but there should be 2 cubic terms. This is also one of the conditions. So 1 is a cubic term, 1 can be written as 1 cube, 64a cube can be written as 4a whole cube. So here can I say I can use the identity a minus b whole cube? Second one is very obvious. Which one? It is a plus b plus c whole square, because there are 6 terms in the expression. Plus and minus, I told you how to adjust while doing that question. Third one, again there are 4 terms. So it should be a plus b whole cube or a minus b whole cube. All positive signs means a plus b whole cube. But do we have 2 cubic terms in this? We have to look for it. It's not necessary that in the beginning itself you will find both the cubic terms, and they can be anywhere in the expression. You have to locate those 2 cubic terms. The first one is 8p cube, which is written as 2p whole cube, and this is not a cubic term, this is not a cubic term, but yes, 1 upon 125 is a cubic term. It can be written as 1 by 5 whole cube. So you know your a and b, and then you can continue your factorization the way I have taught you. Now the fourth one is there are 3 terms. When there are 3 terms, either we can use the identity a plus b whole square, a minus b whole square, or x plus a into x plus b. For all 3 of them, there will be 3 terms in the given expression. How to recognize a plus b whole square and a minus b whole square? It's important that we should have 2 square terms in the given expression, perfect square terms. So do we have? Yes, 4x square is 2x whole square, 25 is 5 whole square, and the middle term is in the format of 2ab, and all plus signs, so it will be a plus b whole square. Skip out 5 and look at the 6th one. Again there are 3 terms. Okay, 3 terms doesn't always mean a plus b whole square or a minus b whole square. It could be x plus a into x plus b as well. Now how to decide? Because for a plus b whole square and a minus b whole square, I need 2 perfect square terms. But here you have only one perfect square term, that is x square. 72 is not a square of any number. So here we can think of applying x plus a into x plus b, for which we do, how do we apply this? It's basically splitting the middle term. Sum should be 17 and product should be 72. So I think 8 into 9 gives you 72 and 8 plus 9 gives you 17. So ax plus 8 into x plus 9 will be the factorization. You can just show all the steps in between for splitting the middle term. And this one is also very obvious. It looks like a square minus b square, but again first we have to write it in the perfect square form as 8x whole square minus 25y whole square. So your a will be 8x, b will be 25y. Don't ever by mistake take 64x as a and 625y as b. First write it in the perfect square form and then choose your a and b. A would be 8x and b would be 25y.